So I got something super cool for you today on Ton Does Linux and more. I'm Adrian, and we're diving into the fascinating world of Linux file systems. You know, those things that actually, organize all your data behind the scenes?
Oh man, I am so excited to talk about this stuff today. File systems are, um, they're actually one of my favorite parts of Linux because, you know, they're kind of the unsung heroes of the whole operating system. And and there's so many cool options out there beyond what most people ever use, right?
Exactly. We've got X4, Btrfs, ZFS, and what was that other one again?
XFS. And and that's just scratching the surface. You know what I mean? There's all these different file systems with different strengths and trade-offs that most people never even think about.
So before we dive into all these different options, I'm really curious. Hmm, What exactly is a file system at its most basic level? I know it's something to do with organizing files, but what's actually going on behind the scenes?
Right. So, at its most fundamental level, a file system is basically just a way to organize data on your storage device, right? It's like imagine you have this massive empty space on your hard drive or SSD, and the file system is what turns that raw storage into something usable, you know? It's it's the structure that keeps track of where all your files are physically located on the disk.
So it's kind of like a filing cabinet for your computer?
Yeah, that's actually a really good way of thinking about it. So like imagine you have this huge filing cabinet with no folders, no labels, nothing that would be your raw storage. And then the file system comes in and creates all the folders, the labels, the organization system that lets you find things, right?
That makes sense.
And and there's a bunch of other stuff that file systems handle too, like permissions. So who can access what files? They handle how data is written to disk. Some have journaling, which is like a safety feature that helps prevent data corruption if your computer crashes. And different file systems make different trade-offs between speed, reliability, features, all that kind of stuff.
So that's why there are so many different options?
Exactly. It's like it's like how there are different car models for different needs, right? Some people need a truck for hauling stuff, some need a compact car for commuting, and and file systems are the same way. Different use cases, different requirements.
So let's talk about X4, which seems to be like the default option for most Linux distros, right? What's the story there?
So XT4 it's basically the standard file system that most Linux distributions use by default. And and it's been that way for quite a while now. It's the fourth generation of the extended file system family, right? The original Ext file system was actually developed way back in 1992, if I'm remembering correctly.
Wow, that's pretty old tech then. How did it become the go-to choice?
Well, that's the thing. The X family has this really long history of just being super reliable, you know? X2 was around for ages. Then X3 added journaling, which was a huge improvement for like preventing data loss if your system crashed or lost power suddenly.
And then came Extra 4?
Yeah, exactly. So X4 was introduced around 2008, and it became stable enough for everyday use by about 2010. And it brought some really nice improvements like larger file size support, better performance, this thing called extents, which helps with file fragmentation, and and it still maintained that rock solid reliability that Linux users had come to expect.
What kind of file sizes are we talking about?
Oh, it's pretty massive. XT4 can handle individual files up to 16 terabytes and volumes up to 1 exabyte, that's like a million terabytes. I mean, for most users, that's way more than they'll ever need, right?
Definitely. So why did it become the standard over other options?
That's a great question. I think it's kind of a perfect balance of factors, you know? First, it's incredibly stable. Like the developers took a really conservative approach with Ext4. making sure it was thoroughly tested before pushing it out. And that means it's just rock solid.
Stability seems pretty important for something handling all your data.
Oh, absolutely. And the second thing is that it's got really good performance without being too specialized. It works well for most workloads, whether you're running a desktop, a small server, whatever. It's the Toyota Camry of file systems, if that makes sense. Not the flashiest, but super reliable and gets the job done for most people.
That makes perfect sense. Any downsides to X4?
Well, yeah, it doesn't have some of the fancier features that newer file systems offer. It doesn't do snapshots natively, no built-in compression, no data deduplication, and once you create an ext4 partition, you can't really shrink it easily, which can be limiting. But for most users, these aren't deal breakers.
So I've been hearing a lot about Btrfs lately. Sounds like it's supposed to be like the next big thing in Linux file systems. What's the deal with that one?
Oh, Btrfs. Yeah, it's really interesting actually. So Btrfs stands for B-tree file system, though a lot of people just call it Btrfs because, well, it's easier to say, right? And it was actually started by Oracle back in 2007, but it's become this collaborative project with contributions from Intel, Facebook, Red Hat, and tons of others.
What makes it special compared to something like X4?
So the thing is, well, Btrfs is what we call a copy-on-write file system, which is like fundamentally different from how ext4 works. When you modify a file in Btrfs, it doesn't just overwrite the existing data. It writes the changes to a new location and then updates the file pointers. And this enables some really cool features.
What kind of features are we talking about?
Oh man, there are so many. The biggest one is probably snapshots. You can take these point-in-time images of your entire file system in literally seconds, and it barely uses any extra space because of that copy-on-write mechanism. It's like, imagine being able to roll back your entire system to exactly how it was yesterday or last week or whenever. Super powerful.
That sounds incredibly useful.
It really is. And there's more. Like, Btrfs has built-in RAID functionality, so you can set up data mirroring or striping without needing any additional software. It does transparent compression to save disk space, data deduplication in newer versions, and it can do this cool thing called subvolumes, where you can have multiple separate file system trees within a single partition.
So with all these advanced features, why isn't everyone using it instead of X4?
That's the tricky part. Btrfs has had some reliability issues historically, especially with its RAID 5 and 6 implementations. There were cases where people lost data, which is like, the worst thing a file system can do. But that was years ago, and the stability has improved tremendously since then.
Are people actually moving to it now?
Yeah, they actually are. Fedora made it their default file system in Fedora 33. SUSE Linux Enterprise has been using it as default for years. Even Facebook uses it on millions of servers. It's definitely gaining traction as those early reliability concerns get addressed.
What about for regular users? Should they consider it?
I think if you're someone who values those snapshot capabilities or needs built-in RAID or compression, Btrfs is worth looking at now. It's much more mature than it was 5 years ago, but just make sure you have good backups, which you should have anyway, regardless of what file system you're using.
Now, I've heard a lot about ZFS as well. That's another alternative, right? What's the story there?
So ZFS is kind of the original enterprise powerhouse file system. It was actually developed by Sun Microsystems back in the early 2000s, and it was revolutionary when it came out. Like truly groundbreaking stuff. And it was designed from the ground up to be this bulletproof file system for enterprise environments where data integrity was, absolutely critical.
What makes it so special compared to the others we've talked about?
Oh man, where do I even start? ZFS has this this incredible focus on data integrity. It uses something called checksumming for all data and metadata, which means it's constantly verifying that your data hasn't been corrupted. And if it detects corruption and you have redundancy set up, it can actually heal the corruption automatically by using copies of the data stored elsewhere. It's like having this self-healing file system that actively protects your data.
That sounds incredibly robust.
It really is. And then there's the storage pooling concept, which is just amazing. So instead of managing individual disks or partitions, ZFS lets you create these storage pools where you just throw disks in and it manages everything. You can add more storage to a pool whenever you want. You can set up different RAID levels within the same pool, and you can create multiple file systems that all share the same pool of storage.
So why isn't everyone using ZFS on Linux then? It sounds perfect.
Well, there's this big licensing issue. See, ZFS is licensed under the CDDL, which is incompatible with the GPL that Linux uses. This creates this weird legal gray area. Some people argue that distributing ZFS modules with the Linux kernel violates the license terms, while others disagree.
That sounds complicated.
Yeah, it's a mess, honestly. Ubuntu decided to include ZFS support directly, kind of taking a stand that it's legally okay. But many other distributions are more cautious. And then there's the memory usage. ZFS loves RAM, like a lot of RAM. The old saying is ZFS would eat all your memory if you didn't need some for other things. It's designed for enterprise servers that have tons of memory, you know?
Despite those issues, would you still recommend it for certain use cases?
Absolutely. If you've got important data, plenty of RAM, and don't mind dealing with potential compatibility issues, ZFS is incredible. It's used by major companies all over to store petabytes of mission-critical data. For a home server where you're storing like family photos, important documents, or media collections, it can be overkill, but man, your data will be safe. Just make sure you have at least 8 GB of RAM and preferably more.
So let's move on to XFS. I've heard it mentioned a lot in certain circles, but I don't know much about it. What makes XFS stand out from the crowd?
XFS it's actually one of my favorite file systems for certain use cases. It was originally developed by Silicon Graphics, or SGI, back in the 90s for their IRIX operating system, and it was designed from the ground up to handle really, really large files and file systems. We're talking about like massive scale here. And it's been part of the Linux kernel since around 2001, so it's pretty mature at this point.
What kind of performance advantages does it have?
So XFS it's ridiculously good at handling large files and high throughput scenarios. Like if you're doing video editing or scientific computing with huge data sets or running databases, XFS just shines in those environments. It uses this technique called delayed allocation. And it has really sophisticated metadata handling, which helps it maintain performance, even when the file system gets close to being full. You know what I mean? Most file systems start to slow down dramatically when they get filled up, but XFS holds up much better.
Does it have any advanced features like Btrfs or ZFS?
Well, it's not quite as feature-rich as those two, but it does have some nice capabilities. It supports online resizing, but only growing, not shrinking, and it has really good journaling to prevent corruption. The thing is, XFS was designed with performance as the primary goal, not necessarily having all the fancy features. It does one thing, and it does it extremely well.
Where would you typically see XFS being used today?
Oh, it's used a lot in enterprise environments, especially for things like media servers, rendering farms, scientific computing clusters, and large database servers. Red Hat actually made XFS the default file system for their enterprise Linux distribution starting with Arel 7, which says a lot about its reliability and performance characteristics.
Are there any downsides people should know about?
Yeah, there are a few limitations to be aware of. Once you create an XFS file system, you can't shrink it. You can only grow it. And its performance with lots of small files isn't always the best. It's really optimized for large files and high throughput. Also, the data recovery options aren't as robust as some other file systems if something goes catastrophically wrong. But in terms of straight-up performance for certain workloads, it's really hard to beat XFS. It's like the Formula One car of file systems. Maybe not the most comfortable for everyday use, but when you need raw speed and reliability with big data, it's outstanding.
So we've covered the major players, but I know Linux has a ton of other file systems as well. Are there any other notable ones that people might encounter?
Oh yeah, definitely. Linux is it's just so versatile with file systems. So one that's becoming really important is F2FS, which stands for Flash-Friendly File System. It was actually developed by Samsung, and it's specifically designed for flash storage devices like SSDs, SD cards, and USB flash drives.
What makes it better for flash storage compared to something like ext4?
So the thing with flash storage is, well, it has very different physical characteristics from traditional hard drives, right? And F2FS is optimized for the way NAND flash memory works. It has better wear leveling, which means it spreads writes across the drive to extend its lifespan. And it's designed to minimize something called the write amplification effect, which can really kill SSD performance over time. So if you've got like a Raspberry Pi using an SD card or a high-performance SSD, F2FS can give you better speed and longevity.
Any other interesting file systems worth mentioning?
Yeah, there's NLFS2, which is really unique. It stands for New Implementation of a Log-Structured File System. And the cool thing about it is that it keeps continuous snapshots of your data, like all the time, automatically. So you can actually go back to any point in time your system was running and recover files from that exact moment. It's pretty mind-blowing when you think about it.
That sounds incredibly useful. Why isn't it more widely used?
It's one of those trade-offs, you know? The continuous snapshots create some performance overhead, and it's not quite as battle-tested as something like ext4. And there's also RiserFS, which was actually pretty revolutionary when it came out. It had some really advanced features for its time and was really good with small files.
I think I've heard some controversy about that one.
Yeah. Unfortunately, RiserFS has a pretty dark history. Its primary developer, Hans Reiser, he was convicted of murder. And development pretty much stopped after that. There's a fork called Reiser 4, with some impressive technical features, but it never gained mainstream adoption. Most people who used RiserFS have migrated to other file systems like XT4 or Btrfs over the years. It's kind of a cautionary tale in the open source world about project sustainability.
So with all these options, how should someone actually choose the right file system? I mean, it seems like there are a ton of factors to consider.
So I think the most important thing to remember is that for most everyday users, the default file system that comes with your distro is probably fine, you know? Like if you're running Ubuntu or Fedora as a desktop, XT4 or whatever they chose it's totally adequate. Totally.
But what about users who have specific needs or want to optimize their system?
That's where it gets interesting, right? So if you're running a home server with important data, Btrfs or ZFS might be worth considering because of those snapshot features and the data integrity checks. Like if you're storing family photos and videos that are irreplaceable, the ability to recover from corruption it's honestly priceless.
What about performance considerations?
Yeah, so if performance is your absolute priority, like you're doing video editing or running databases, XFS might be your best bet, especially if you're dealing with larger files. It's just It's really good at handling those high throughput workloads, you know? And for SSDs in particular, either F2FS or X-T4 with the right mount options can give you the best balance of performance and longevity.
Are there any hardware limitations people should know about?
Oh, absolutely. So, ZFS is kind of notorious for being memory hungry. If you've got less than 8 gigabyte of RAM, you might want to think twice before using it. And Btrfs, while it's gotten more stable, I still wouldn't recommend it for like mission critical RAID 5 or 6 setups. The code for that is still considered experimental.
What about future proofing? Like, if someone is setting up a new system today,
That's a great question. I think if you're setting up something new and you want it to be somewhat future proof, Btrfs is probably your best bet among the mainstream options. It's got good development momentum, it's being adopted by major distros like Fedora, and it has that modern feature set that's only going to get better. But the most future-proof approach might actually be to use something like LVM, which lets it lets you change file systems later without reformatting everything.
do you have a personal favorite that you use for most of your systems?
I'm actually kind of boring. I still use X4 for most of my everyday systems because it's just so reliable and I know it inside out. But for my home server where I keep all my like important data, I've moved to ZFS and I just love the peace of mind it gives me. The snapshots have saved my bacon more than once, let me tell you.
So what do you see happening with Linux file systems in the next few years? Any major trends or developments on the horizon?
So I think we're at this really interesting point right now where file systems are they're evolving beyond just storing files, right? Like the whole concept of what a file system does is expanding. And I think we're going to see Btrfs continue to mature and probably become the new default for most distributions in the next 5 years or so. Fedora is already there, and others will follow, you know?
What about X4? Is it on its way out?
Oh no, not at all. X4 is it's like that reliable old friend that's going to stick around forever. It's so deeply embedded in Linux that it'll be supported for decades. But I do think we'll see less active development on it. The cutting edge work is happening elsewhere, right? The interesting stuff is in copy on write systems like Btrfs and ZFS.
And what's the future looking like for ZFS specifically?
ZFS is, well, it's complicated because of the licensing issues. But technically, it's still years ahead of the competition in some ways. I think we'll see continued development through the OpenZFS project, and maybe, just maybe, we might see some resolution to those licensing problems. There's also this project called Stratus that's trying to bring ZFS-like features, but with a fully open license. That's something to watch.
What about totally new file systems? Any fresh concepts coming up?
Yeah, there's some really cool experimental stuff happening. Like there's Btrfs that's trying to integrate the file system with caching. And there's work on persistent memory file systems that blur the line between storage and RAM. Oh, and I'm really excited about these distributed file systems like Ceph becoming more accessible to normal users, not just big enterprises. That's going to be huge for home labs and small businesses. You know what I mean?
Do you think SSDs and new storage technologies will drive changes in file systems?
Absolutely. That's actually one of the biggest drivers right now. F2FS was just the beginning. We're seeing new storage technologies like NVMe and persistent memory that are so fast that our current file systems are actually becoming the bottleneck. So I think we'll see more specialized file systems that are really optimized for specific hardware. And the whole concept of journaling might change because the performance trade-offs are different with these super fast drives.
Sounds like an exciting time for what most people would consider a pretty boring topic.
Right? Like file systems are this hidden technology that nobody thinks about until something goes wrong. But they're actually at this amazing intersection of performance, reliability, and features. And and the cool thing is that Linux gives you all these options that you just don't get in other operating systems. It's one of the things that makes Ton Does Linux and More so much fun to talk about. These under the hood technologies that make a huge difference in how your system actually works.
So that pretty much wraps up our journey through the world of Linux file systems today. Any final thoughts you'd like to share before we close out, Ton?
Yeah, I think the big takeaway here is that Linux gives you this amazing freedom to choose the right tool for the job. You know, like if you want rock solid stability, there's ext4. If you need snapshots and modern features, Btrfs is probably your go-to. For enterprise stuff with huge storage requirements, ZFS is incredible. And for those big files and high performance needs, XFS is still, and, and it's still really hard to beat.
I've learned so much today. It's fascinating how something as fundamental as a file system can have such different characteristics.
Exactly. And the cool thing is, well, you can actually mix and match these on different partitions based on what you're doing. Like maybe use ext4 for your system files, but Btrfs for your data, right? Linux is all about that flexibility.
Before we go, any quick advice for someone who's not sure which file system to pick?
So if you're new to this, just stick with whatever your distribution defaults to. That's usually ext4, and it's fine for most people. But when you're ready to explore, maybe try Btrfs on a non-critical system and play with snapshots. That's honestly the best way to learn.
Thanks so much for sharing all this knowledge today. And thank you all for listening to another episode of Ton Does Linux and More. If you enjoyed this deep dive into file systems, make sure to subscribe for more Linux content coming your way.
Yeah, thanks everyone. And remember, your file system choice it's kind of like picking the foundation for your house. It's worth spending some time to get it right. You know what I mean?
Absolutely. See you all next time.